Okay guys, starting week 2 here with section 1.4. We're going to be dealing with quadratic equations. First, let's just take a quick recap here and look at linear equation. And this is what you guys have been working with here just last week, of course. This is something of the form like ax plus b, or you could even have x or 4x minus 3. It's linear, again, because your variables are raised to the power of 1. So mess that up there on the top. But just verbalizing here, your variables are the power of 1. So just keep that in mind for linear. For a linear equation. For a quadratic equation, these are more of the form, something like this, where you have x squared plus x minus 3. And you know it's quadratic simply because the power of 2, it's greater than 1. So any variable that has a higher exponent that is greater than 1 or greater, it's a quadratic equation or a higher degree equation, so therefore obviously it's not linear. Another example would be something like this. There's multiple examples you can come up with, just as long as your variable is squared. The next thing you guys should really make sure that you remember, I mean, this is you have to know this. Simply because if you don't do this every time, you're going to get the wrong answer every time, and it's something you have to do at the very beginning. And what that is you always have to set your entire equation equal to 0. So if you had an example like equals, you have x squared minus 3 equals x, before you can start factoring to solve for x, you need to bring this x over to the left hand side, so that way you set the whole one side equal to 0. So what we would do here is we just simply subtract x, and you would come up with something of the form like this. And this right here is what you want to do. Every single problem you want to make sure that the equation is equal to 0. And this is again pulling all your variables and all your constants over to one side. So if it was set up like this, where you had that, again, you can't solve it until you subtract this 3 over, and you would have something like this, of course. Right here is very important. If you don't do that, you're going to end up with the wrong answer every time. So make sure you know this. It's very important. Thank you. Okay, let's move on to an example of solving by the zero factor property. So this is your zero factor property. Let's do, I don't know, something like this. Okay, now like we just saw, we had a, want to make sure we always do this. I wrote like this at the very top left corner. This is not in the correct form yet, so you start solving. So what we need to do automatically every time is get everything to one side so it's equal to 0. It's very important. And from there, now we can start factoring. And by factoring, you might remember this from previous classes, is where you start doing the, you pull out your parentheses and you try and figure out how you can break this equation down into two parentheses that are going to multiply together to come back to your original equation if you needed to. So the first thing to do is you're going to have x squared as your first outcome. So you want to make sure that at least you have the x's up front. But you can also see there's a constant here, and you need to split that up too. So you're going to look at, you're going to break down 10 and figure out what two numbers multiply together to get 10. Well, in that case, it's 2 and 5. So go ahead and stick the two constants that we just found over here on the left in front of each one of those x's. So now you've taken care of this one so far. So put a little check there to make sure you know you got it there. The next thing to look at is your n constant here. And you want to find out what two numbers multiply together to get that. Well, two numbers that multiply together to get 2, or in this case -2, well, there's only two numbers, and that's going to be a 2 and a 1, and obviously one of them has to be negative. So that should be a tip-off that one of these parentheses is going to be a negative and one of them is going to be a positive. Simply because your end number here, -2, is negative, so you have to multiply a negative and a positive together to get that negative. So let's just go ahead and plug in your 2 and your 1. So now if you wanted to check this to make sure that this is equal to that, you could go ahead and FOIL it out, but I've already done that for you, so I don't want to waste time doing that. But if you guys want, you could check and do that yourselves. So now the whole zero factory property is going to come into effect here, and what that is you're going to take one of the pieces of one of the parentheses, we'll take this one first, and we're going to set it equal to 0. And then we're going to take the other one and also set it equal to 0. And in this case, you're simply going to solve for x in each one of them and figure out which one is your answer, or maybe both of them will be. So it's just something that we'll do next. So to do this one here first, the left one, we're going to go ahead and add 2 to both sides. So you got 5x equals 2. And of course we want to get x by itself, so we're going to divide both sides by 5, and you're going to have 2 over 5. So now moving over to the right hand parenthesis, we want to subtract 1. So in that case you're going to have 2x equals -1. And you want to get x by itself again, so divide by 2, and you end up getting -1/2. So in this case you have two answers, and what you could do if you wanted, you could take both of these answers, one at a time of course, and plug it in back up here for x, x squared and for x. So you'll plug, in this case, you'll plug in 2/5 for x squared and for x, and then see if that works out to be in 2, which, like I've already done, it does do. And then you can come over here and check this one if you want, which is -1/2, and you can plug it in up here for x squared and x, just to verify that your answer are these two. The way some people might want you to report the answer back to you is in something like this. Basically the solution set. And these are just little curly brackets on the left and the right. I'm sure you guys have seen that. So that's all you have to do for this problem.